Forged. How tires are made. Over 1.5 billion tires are produced every year. Every car, every truck, every plane, every bicycle depends on them. They connect everything that moves on land to the ground beneath it. And the engineering inside a single tire, built from over 200 components, is extraordinary. This is how they are actually made. It starts in a jungle. The primary raw material for tires is natural rubber, tapped from Hevea brasiliensis, the rubber tree, grown on plantations primarily in Thailand, Indonesia, Malaysia, and Vietnam. Workers score the bark of each tree with a curved knife, cutting just deep enough to reach the latex vessels beneath without killing the tree. Milky white latex drips slowly into collection cups. Each tree produces about 5 liters of latex per week during tapping season. The latex is collected, mixed with formic or acetic acid to make it coagulate, and processed into sheets that are dried or smoked into pale yellowish bales. Natural rubber alone is not enough. Synthetic rubber, primarily styrene-butadiene rubber derived from petroleum, is blended with the natural rubber to fine-tune the compound's properties for different parts of the tire. Tread needs grip and wear resistance. Sidewalls need flexibility and weather resistance. The inner liner needs to be airtight. Each zone of the tire uses a different rubber formulation, and a modern tire plant may manage dozens of distinct compound recipes simultaneously. Then there is carbon black. Natural rubber is a cream or tan color. Every tire you have ever seen is black, and that color comes entirely from carbon black, a fine powder that is almost pure carbon, produced by burning hydrocarbons in low oxygen conditions. It is added to the rubber compound in significant quantities, and it transforms the material. Carbon black reinforces the rubber matrix at the molecular level, increasing tensile strength and abrasion resistance by roughly a factor of 10. Without it, a tire would wear out in a few hundred miles. It is the single most important additive in the compound. The tire is built from the inside out on a rotating drum. First comes the inner liner, a special rubber compound, similar to a butyl rubber, that is nearly impermeable to air. This replaced the inner tube. On top of the liner go the body plies, layers of nylon or polyester cords embedded in rubber, running diagonally across the tire. These plies give the tire its structural integrity, allowing it to maintain its shape under load and pressure. Steel bead wires are then placed at the edges. These are the rigid hoops that lock the tire to the wheel rim. The sidewall rubber goes on next. The steel belt package is the most critical structural element. 4 layers of fine steel cords, each cord made of multiple individual wires twisted together, are embedded in rubber and placed around the circumference of the tire, running at opposing angles to each other. These belts are what give a radial tire its stability at speed and its resistance to punctures. The cords run almost horizontally, stiffening the tread area and reducing the footprint deformation that causes heat buildup. On top of the belts goes a cap ply, a final layer of nylon that holds everything together at high speed. Then the tread rubber is applied. The assembled structure at this point is called a green tire. It has all the right components but is chemically uncured. The rubber is still soft and pliable. The green tire goes into a mold, which has the tread pattern cut into its inner surface. The mold closes, and a bladder inside the tire inflates under high pressure, pushing the green tire outward into the mold. Then heat is applied, around 170 degrees Celsius, for 10 to 20 minutes, depending on the tire size. This is vulcanization. The process was discovered accidentally by Charles Goodyear in 1844 when he dropped a rubber sulfur mixture on a hot stove. The heat causes sulfur to form cross-links between the long rubber polymer chains, changing the material from a soft, tacky, temperature-sensitive substance into a resilient, elastic solid that maintains its properties across a wide temperature range. Without vulcanization, rubber melts in summer heat and cracks in winter cold. With it, it lasts for 50,000 miles of road contact. The tread pattern pressed in by the mold is permanent. After molding, the tire goes through quality control that would surprise most people. Uniformity testing mounts each tire on a precision machine that rotates it at speed and measures force variation around the circumference. Any imbalance in mass distribution or stiffness is detected and flagged. X-ray inspection checks for internal structural defects invisible from the outside. Steel cord separations, voids, contaminants. Tires that fail any test are destroyed. The rejection rate at high-quality tire plants is typically under 1%, but the testing is comprehensive on every single unit. The tire on your car right now contains natural rubber from a tree in Southeast Asia, synthetic rubber from a petrochemical plant, steel cords from a wire mill, nylon or polyester fabric from a textile producer, carbon black from a combustion process, sulfur from petroleum refining, and dozens of chemical additives. It was built by hand on a drum, cooked in a mold, x-rayed, spin-tested, and balanced before anyone was allowed to put it on a vehicle. And most people never think about it for a single second. Follow Forged, how the things you love are actually made. Link in bio.